All right. Today I want to talk about artificial life. Um, Artificial life. Um, there are a lot of different types of ALife. There's soft ALife that is a program. There's hard ALife where it's a hardware kind of thing. And there's wet ALife where they're actually fiddling with the biochemistry of things to make living creatures in chemistry. Clearly, we're going to talk about the soft variety, and this too comes in a number of different flavors. One is cellular automata. We'll play Game of Life later, but there's also neural networks, and some varieties even include the possibility of evolution, where the ALife creatures breed and they pass on desirable traits that enhance their survivability. We won't be doing that. Ours is simple, non-evolving, rule-based CA. In the simple world, we'll have two types of creatures, a vegetarian prey and a carnivorous predator, each of which are associated with a nest into which they're born and which they consider to be their home base. For the prey characters, the nest is a sanctuary in the sense that predators can't eat them when they're in the nest. Both creatures have a health as well as some basic needs. They have hunger, thirst, and rest. Hunger is satisfied by eating food, thirst by drinking water, and rest by being in the nest. And the creatures also can reproduce, where a new additional creature is added to the nest. We start all these at either 100 or random values, and at regular intervals, these desires decline. There's a life cost where every 2 seconds, health and rest lose 2 and thirst loses 3. As these decline, various needs and hence behaviors are triggered. It's sort of like a state machine. For the prey, hunger less than 70 leads to searching for food, thirst less than 70, searching for water, and rest less than 70 sends them back to the nest. Predators, hunger limit is 90, thirst 70, and rest of 10 sends them back to the nest. Searching in each of these cases involves finding the closest example of a desired category. Hungry prey will look for food objects, whereas hungry predators will look for prey. In the life cost function, which is, we're scheduling most of these with invoke repeatings. We'll also assess the damage caused by various values with a calculate damage function. These each work the same way, and when we get done, we have a total damage that's the sum of the food, thirst, and rest damage. If total damage is positive, we add it to the health, which brings them back to life, and if it's negative, we subtract it from the health. If health ever goes negative, or we have an unfulfilled need, that is, something's looking for a category and it's not there, then they die instantly. Calculate damage looks like this. Positive points are returned for values greater than 60, greater than 35 return 0, greater than 25, -1, and so forth, returning various damages that are then added into the food, thirst, rest, and total damages. Reproduction is handled by a recursive function that is invoked with a random time delay between 25 and 60 seconds for prey, between 45 and 80 seconds for predators. that instantiates a new creature, adding it to its parent's nest. And we do have a cap on the numbers allowed. Otherwise, this sometimes overwhelms the system as we get too many of any particular creature. Um, uh, and notice it's recursive. Reproduce invokes reproduce if there are too many, and it tries again at some later time. If it gets through those bailouts, it'll instantiate a creature, give it a random position, uh, and spawn it and set its parent. Depending on the parent's type, it sets up various random statistics. For prey, it has a random movement speed, a little range and movement speed, and a little bit of scale here. I don't think I actually changed the scale much. Predators, they're not friendly, so they're false. They also have a random movement speed and scale. All of this is set up and maintained by a resource spawner object with the spawn resources script that has slots for the various prefabs, food, water, and nests, how many of each you want, max number of predators and prey, a seed for the random number generator, and I think some other settings that I won't mention here. The scripts also ensure that resources don't run out, food and water, and that there's always at least one predator and 2 prey nests, as sometimes they die out as well. Food and water objects decrease in size as they are touched by creatures and disappear when they get too small. And all of this is done on a nav mesh. So the food and water objects are nav mesh obstacles so that creatures can navigate around them. This can be laggy, but it does work. You can turn this off if it's too laggy. And the nests also have UI elements that keep track of the population of a particular nest. And as you'll see, the creatures are color-coded as to what their current state is, whether they're hungry, thirsty, or returning to the nest. In subsequent videos, I'll show you examples of the behavior of each of these things. And of course, you can play with them yourself. This is it over here. Here's kind of an example. Running on a terrain, and I'm not going to let this go to completion. I'll do that in separate videos. So have fun. I'll see you in class. Stop sharing and recording. See you in class. Bye.